NENOMATICA, where mathematics meets YouTube excellence. The seventh law of power. Welcome to our math lesson on simplifying expressions with negative exponents. Today, we're going to work through several examples step by step, applying the rules of exponents to simplify complex expressions. Let's start with our first example. We need to simplify the expression n to the power of negative 2 times m divided by 7 times m to the power of negative 4 times n to the power of negative 3. First, let's apply the negative exponent rule, which states that a to the power of negative n equals 1 divided by a to the power of n. This will help us convert negative exponents to positive ones. Now, we can simplify this by bringing all the denominators up. In the numerator, we have 1 over n squared times m. In the denominator, we have 7 times 1 over m to the 4th times 1 over n cubed. We can further simplify this by rewriting the denominator. We have m over n squared divided by 7 over m to the 4th times n cubed. When dividing by a fraction, we multiply by its reciprocal. So this is equivalent to m over n squared times m to the 4th times n cubed over 7. Now, we can multiply the numerators and denominators. In the numerator, we have m times m to the 4th times n cubed, which gives us m to the 5th times n cubed. The denominator is n squared times 7. We can simplify the expression further by using the law of exponents for division. For n, we have n cubed in the numerator and n squared in the denominator, so we get n to the power of 3 minus 2, which is n to the first power. Now, let's move on to our second example. We need to simplify the expression 5 times x to the power of negative 1 times y to the power of negative 4, divided by the quantity 3y to the power of 5 to the power of negative 2 times x to the power of 9. First, let's deal with the power of a power in the denominator. The rule states that when we have a power of a power, we multiply the exponents. So 3y to the power of 5 to the power of negative 2 becomes 3 to the power of negative 2 times y to the power of 5 times negative 2, which is 3 to the power of negative 2 times y to the power of negative 10. Now, let's apply the negative exponent rule. We have 3 to the power of negative 2 in the denominator, which becomes 3 squared in the numerator. So our expression becomes 5 times x to the power of negative 1 times y to the power of negative 4 times 3 squared, all divided by y to the power of negative 10 times x to the power of 9. Let's simplify the numerator. 5 times 9 is 45, and we apply the negative exponent rule for x to the negative 1 and y to the negative 4. This gives us 45 divided by x times y to the 4th power. Now, applying the negative exponent rule to y to the negative 10 power in the denominator, we get y to the 10th power in the numerator. Our expression becomes 45 times y to the 10th power divided by x times y to the 4th power times x to the 9th power. Simplifying further, we combine like terms. In the denominator, x to the 1st times x to the 9th becomes x to the 10th. For the y terms, we have y to the 10th divided by y to the 4th, which gives us y to the 6th. So our final answer is 45 y to the 6th power divided by x to the 10th power. Let's look at one more complex example. We need to simplify the quantity 24 cubed b to the power of negative 8 over 6a to the power of negative 5b, all raised to the power of negative 2. First, let's simplify the expression inside the parentheses before applying the negative 2 power. We'll start by simplifying the numerical coefficient. 24 divided by 6 is 4. Now, let's deal with the variables and their exponents. For the terms, we have a cubed in the numerator and a to the power of negative 5 in the denominator. Using the law of exponents for division, we get a to the power of 3 minus negative 5, which is a to the power of 8. For the b terms, we have b to the power of negative 8 in the numerator and b to the power of 1 in the denominator. This gives us b to the power of negative 8 minus 1, which is b to the power of negative 9. Now we apply the power of negative 2 to the entire expression. Using the power of a product rule, we distribute the negative 2 exponent to each factor. This gives us 4 to the power of negative 2 times, a to the power of 8 times negative 2 times, b to the power of negative 9 times negative 2. Let's simplify each term. 4 to the power of negative 2 is 1 over 4 squared, which is 1 over 16. A to the power of 8 times negative 2 is a to the power of negative 16. Finally, b to the power of negative 9 times negative 2 is b to the power of 18. Using the negative exponent rule, for a to the negative 16, we get 1 over a to the 16th power. So our final answer is b to the 18th power divided by 16 times a to the 16th power. To summarize what we've learned today about simplifying expressions with negative exponents, first, remember the fundamental negative exponent rule. A to the power of negative n equals 1 over a to the power of n. Second, when simplifying complex expressions, break down the problem step by step, applying one rule at a time. Third, you can use various exponent rules together, such as the power of a product, the power of a quotient, the power of a power, and the laws of exponents for multiplication and division. By following these principles, you can simplify even the most complex expressions with negative exponents. In this video, we'll learn how to simplify algebraic expressions with negative exponents and convert them to expressions with only positive exponents. Let's start with our first example. We have the expression 2x to the fourth y to the negative 1, all divided by x to the negative 6 y to the third. To convert this to an expression with positive exponents only, we need to apply the rules of exponents. First, we'll rewrite the expression to move all negative exponents from the numerator to the denominator and vice versa. For y to the negative 1 in the numerator, we move it to the denominator as y to the positive 1. For x to the negative 6 in the denominator, we move it to the numerator as x to the positive 6. Now we can simplify by adding the exponents of like terms. In the numerator, we have x to the fourth times x to the sixth, which equals x to the 10th. Let's move to our second example. We have m to the negative 2n to the negative 10 divided by m to the negative 7n to the negative 3. Again, we'll move all negative exponents to the opposite position. From the numerator, m to the negative 2 goes to the denominator as m to the positive 2, and n to the negative 10 goes to the denominator as n to the positive 10. From the denominator, m to the negative 7 comes to the numerator as m to the positive 7, and n to the negative 3 comes to the numerator as n to the positive 3. Now we simplify by adding the exponents of like terms. For m, we have m to the 7th in the numerator and m to the 2nd in the denominator, giving us m to the 5th in the numerator. For our third example, we have the expression open parenthesis 2p squared, close parenthesis to the negative 3, times q to the fourth, divided by open parenthesis 6q close parenthesis to the negative 1, times p to the negative 7. This example is more complex because we have a negative exponent applied to expressions in parentheses. Let's first distribute the exponent negative 3 to the term 2p squared. Now, we move all negative exponents to the opposite position. 2 to the negative 3, p to the negative 6 from the numerator go to the denominator. 6 to the negative 1, q to the negative 1, and p to the negative 7 from the denominator go to the numerator. Let's simplify this expression. In the numerator, we have q to the fourth times q to the first, which is q to the fifth. We also have p to the 7th and 6 to the first. Now, we simplify the exponents of p. We have p to the 7th in the numerator and p to the 6th in the denominator, giving us p to the first power in the numerator. We can further simplify by dividing both the numerator and the denominator by their greatest common factor, which is 2. Now let's look at our fourth example, which is more complex because it involves a negative exponent applied to a fraction. Open parenthesis z squared y to the negative 1x to the negative 3 over x to the negative 8z to the sixth y to the fourth close parenthesis, all raised to the negative fourth power. First, let's simplify what's inside the parentheses. We'll move all negative exponents to the opposite position. Now we combine like terms inside the parentheses. Since z to the negative fourth appears in the numerator inside the parentheses, we move it to the denominator. When you raise a fraction to a negative power, it's equivalent to flipping the fraction and raising it to the positive power. Finally, we distribute the exponent 4 to all terms in the numerator and denominator. In this video, we'll solve an expression involving negative exponents. Here's our problem. 4 raised to the power of 0 times 2 raised to the power of negative 2 divided by 3 raised to the power of negative 1 times 4 raised to the power of negative 2. Let's solve this step by step. Remember that a negative exponent means we take the reciprocal of the base raised to the positive exponent. So for any non-zero number, a to the power of negative n equals 1 over a to the power of n. Also, for any non-zero number, a to the power of 0 equals 1. This is a fundamental property of exponents. Step 1. Let's rewrite the expression with positive exponents only. In the numerator, we have 4 to the power of 0, which equals 1 times 2 to the power of negative 2. Using our negative exponent rule, 2 to the power of negative 2 equals 1 over 2 squared. In the denominator, we have 3 to the power of negative 1 times 4 to the power of negative 2. 3 to the power of negative 1 equals 1 over 3, and 4 to the power of negative 2 equals 1 over 4 squared, which is 1 over 16. So now our expression is 1 over 4 divided by 1 over 48. Remember, when we divide by a fraction, we multiply by its reciprocal. So 1/4 divided by 1/48 equals 1/4 times 48/1, which gives us 48 divided by 4 is equal to 12. Actually, let's take a step back and solve this again using the approach shown in our reference solution. The reference solution rewrites the negative exponents in a different way. Step 1. We'll rewrite the expression with positive exponents directly. Using the negative exponent rule, we can bring the terms with negative exponents from the numerator to the denominator and vice versa, changing their exponents to positive. So our expression becomes 4 to the power of 0 in the numerator, 4 to the power of 0 in the numerator, and 2 to the power of 2 in the denominator. For the terms in the denominator, 3 to the power of negative 1 becomes 3 to the power of 1 in the numerator, and 4 to the power of negative 2 becomes 4 to the power of 2 in the numerator. Step 2. Now we'll simplify the expression. 4 to the power of 0 equals 1. 3 to the power of 1 is just 3. 4 to the power of 2 equals 16. And 2 to the power of 2 equals 4. So our expression becomes 1 times 3 times 16 divided by 4. Step 3. Let's compute the final answer. 1 times 3 is 3, and 3 times 16 is 48. So we have 48 divided by 4, which equals 12. Therefore, our final answer is 12. Let's start with our first example. We need to simplify the expression 2/3 raised to the power of negative 3. To solve this, we'll use the negative exponent rule. When we have a negative exponent, we can rewrite it with a positive exponent by taking the reciprocal of the base. Now, we can evaluate this positive exponent. We calculate 3 to the power of 3 divided by 2 to the power of 3. Let's compute these powers. 3 cubed equals 27, and 2 cubed equals 8. Now, let's move on to our second example. We need to simplify negative 3 raised to the power of negative 2. Again, we'll apply the negative exponent rule, but we need to be careful with the negative sign inside the parentheses. Now, we can calculate the denominator. Negative 3 squared equals 9, since the negative sign is squared as well. For our final example, let's simplify negative 1 raised to the power of negative 1. Just as before, we'll apply the negative exponent rule to rewrite this with a positive exponent. Now, we simplify the denominator. Negative 1 to the power of 1 is just negative 1. And 1 divided by negative 1 equals negative 1, which is our final answer. Let's summarize what we learned. When dealing with negative exponents, we can rewrite them using the reciprocal of the base with a positive exponent. For fractions with negative exponents, we invert the fraction and make the exponent positive. And when dealing with negative numbers raised to exponents, we need to be careful to follow the correct order of operations. Challenge: can you explain why the negative exponent causes the base to invert? Try applying this rule to the fraction 4/5 raised to the power of negative 2 on your own. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.